Hello everyone and welcome to the lab video for Grantham Physics 220 for week 5. This is lab 5 work and power, so please go back and review any the basics in chapter 6. And we're going to do a little bit of an interesting one here. We're not going to use the interactive, nor are we going to use a spreadsheet, although you can use it for calculations. We are actually going to use ourselves. So this lab involves walking up a flight of stairs and recording your time via a stopwatch or a chronograph, which basically means a stopwatch. Now, a couple things I want to add into this. If you don't have a stopwatch, it doesn't have to be horribly exact. A clock works good. If you have a smartphone, which a large portion of people do, there are multiple stopwatch apps that work very, very well. You can even set timers and whatnot. So there's no need to go out and buy a stopwatch. There's always items you can do to calculate this. Even the second-hand clock, if you had a non-smartphone but it would read down to the seconds, will work fine. So you'll be asked to make measurements and calculations for the total time, the work of the stairs, at least 7 steps. So I'm going to show an example of my stairs, and the vertical height of the stairs from the top to the bottom. That may be a little difficult for some people, and one thing I could suggest if you have no way to easily measure the height is just do an easy approximation, measure the height of one stair. Let's say it's 10 centimeters and you have 8 stairs, then you can estimate that's going to be 80 centimeters or 0.8 meters, and it's probably going to be much more than that. It's probably going to be, each stair is probably going to be close to about 20 to 25 centimeters. So if you can't measure down the side, let's say you're on a stairwell that has walls on both sides, just measure the height of each stair and then multiply it out. Then you're going to go through this and make a series of calculations based on the basic properties of work and power, and then we're going to do something interesting. We're going to make a calculation of how much it would have cost you to walk up the stairs if you were using electrical power, for example. So you see the next thing we have here is the answer sheet for the lab, and notice you have weight, your work, power in kilometers, and then the money that this climb is worth. Now, if you don't want to put your own weight, fine. Just assume an average person has a mass of about 100 kilograms, and that's going to determine your weight. The reason why this is important is, remember, weight is mg, and the important thing here is the work is going to be the work and force involved, so times the distance, which is then going to be mg times the height of the stairs. So that's going to be the amount of work you expend while going up the stairs. Now the power is then going to be the work, divided by time. So that's what you're then going to calculate this out. So now we want to look at what we're actually going to do here. Okay, so you see I have a picture of my stairs here, and what you're going to do is you're literally going to, down near the bottom, and it's not the greatest image I have here, you're going to start your timer, and you're going to walk up stair to stair to stair to stair until you get to the top, which if I bring this down you can see where the top is, and then you would stop. Okay, I would, since it's a lab procedure, try to do it a couple different times, meaning you want to do a couple different runs, going roughly at what you think the same rate is. That way you can make sure to get a good value. Maybe do at least 3 or 4 times and average the time. Assume you have the distance all the same, so you're not going to have any issues there. And remember what I said, if you don't know the exact height, and even mine would be a little bit difficult, it is open to the right, but to the left it's a big wall. Measure the height, say from here to there, and maybe even do it over, say, 3 stairs and average them. But don't do it for all of them. I mean, like I say, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I have about 13 stairs. So I'd probably measure about 3 of them, take an average, and then multiply that by 13. So then at that point, then I'll walk you through on the, how we're going to actually sit down, calculate these, and go through each step and figure out exactly how much each of these is going to cost, or be, and then at the end I'll also bring up a nice cost function based on an average value I have in my area for how much a kilowatt hour actually costs. So at this point you should have calculated, like I mentioned about, you should have your weight, You should have the work you've done where the distance here is the height of your stairs. And then you should be able to have calculated the power you exerted. How much work you did divided by time. I mean, you may want to at this point put in like a time in seconds here. So that you have a nice place to record that also. So then you should have how much that is. Now, notice work here is going to be in joules. Okay. Time is going to be in seconds. Power is going to be in joules per second, which is a watt. And I'll specifically write that out. It doesn't really help that work and watt have the same units. Kilowatts is just watt, divided by 1,000. You know, the number of watt divided by 1,000. Now the next thing they say is money that the climb is worth. And there's a little bit of interesting thing you're going to have to do that. To do this. What you pay for when you pay for energy or get your bill from the electric company or the gas company is you actually pay for energy, not power. Meaning it's the actual amount of energy that was exerted when you did this to determine how much you spent, which is good because if you paid for power, you'd be determining being charged by how fast and how much you used. So what you're going to have to do with this one is you're going to actually have to calculate the work emitted. But the problem is more than likely you're going to need work in what's called kilowatt hours. And what this is if we use the relationship that 1 kilowatt hour equals 3 million, put the commas in there, 600,000 joules, you can determine this. Now there's a reason why we want to do that. So then the other thing we need to do is figure out how much a kilowatt hour is right now, and usually it's about 12 cents per kilowatt hour. So once you can convert your work into kilowatt hours and multiply how many joules you exert going up the stairs, you can figure out how much that would have cost you. And again, the interesting thing is it doesn't matter if you did it in 30 seconds or if you did it in an hour. It's all the amount of energy that would be used if you were paying something to do it, or how much it actually draws. Well, that draws us to a close this week. I hope you've enjoyed what we've done here. And again, if you have any questions at any time, please email your instructor.